We're going to be talking about deductive proofs, as it says up here at the top. And we'll use the alternate exterior angles relationship as a starting point. Now, with proofs, we have certain parts of the proofs. Right? We have our figure, diagram. We have what we're trying to prove, and the givens. These are, of course, very important. Now, this is by no means an example of a truly rigorous proof. I'm allowing you some pretty high-level assumptions, which will make it a little bit easier, to be honest, so that we can really focus on how to construct a logical argument, a deductive argument. For this example, as it says down here, we're going to create a flow map. Now what I'll do is we'll start off with a flow map and then from there go into a standard two-column proof. And you can see how the two relate to each other. Now for this class, knowing what's given is going to be a big help because it's hints. These you can think of as hints as to the direction to go in. Now, will we be using everything in this list? No. Usually there's more there than is needed. But we will, you can really only use these in your reasoning. One of the things with proofs is we want to limit the amount of assumptions we're making and just use those. So when we start trying to prove this, now we've already covered in class that alternate exterior angles are in fact congruent. So we're kind of going back in time and saying, well, if we weren't told that, how could we figure it out? And the way we can do it is by using a third angle. If we remove the relationship that connects them directly, then what's left is having to go indirectly. For example, using that angle right there, which we'll label as C. We can create a nice logical argument because, of course, A and C are what kind of angles? Well, they're opposite angles or vertical angles. Now we have to check, can we use that? Yep, it's in our givens list. Opposite angles are congruent. We can use that relationship. So we can say that A and C are the same. Well, what about B and C? Well, what kind of angles there? They're corresponding angles. Well, is that in our givens list? Yep, corresponding angles of parallel lines are congruent. So that's a legal move to make. All right. Well, if A equals C and B equals C, can't we say connect A and B? And the answer is yes. So let's see how we can do that. So if we come down here and try to create a flow map, we can start off with what we just talked about. And we can establish the relationship that angle A is congruent to angle C. And how do we know that's true? We know it because opposite angles are congruent. Right? And we can put that in a box. Now, separately, so we'll put it in a different box. We could say angle B is congruent to angle C. And the reason we know that is true is because corresponding angles are congruent. Now we can combine these. Right, this is called a flow map because we have arrows that show you the flow. Right? We're going from these two statements, we're combining them to produce a third statement, right, which is going to be angle A is congruent to angle B. Notice that's what we were trying to solve for, or what we're trying to prove. We're actually not solving for anything. And now we have to think about, well, how do we get from these two to this? And what we can do, there's a couple ways of doing it. One is an algebraic property called the transitive property. There is another algebraic property which I kind of like for this, which is the substitution property. So down here, and one of the reasons why I like it is that it's easy to diagram. We have angle C is the same as angle B. That's what this statement is telling you. So up here, wherever we see angle C, we could do a substitution. We could substitute B in for C. And if we do that, we get this statement. So the reason we can say A is congruent to B at this stage is that we can substitute angle B in for angle C. And we have proven what we've wanted to prove, and we've created a nice little logical flow map to do it. Now, if we wanted to do this in a more traditional two-column proof, as it's called, then maybe I can squeeze it in over here. It's not a lot of space. So this is going to be taking this flow map and converting it. So this isn't anything new. I just want everyone to be sure you understand that I'm just rearranging the same information into another format. Some people like the flow map, some people like the two-column, because the two-column separates statements and reasons. It's a different organization. So we'll start off with this first box, which is the statement is that angle A is congruent to angle C. The reason we can say this is that opposite angles are congruent, right? So you can see really this is statement and that's reason. So this one has to come next. We can't go to this box because we need these first. So we can say angle B is congruent to angle C. Corresponding angles are congruent is the reason we know this is true. And then we can say angle A is congruent to angle B, again with that algebraic property of substitution. We're going to substitute. I do like not just saying substitution property, but actually saying what you are substituting in where. So we can say substitute angle B in for angle C. And I find that a little bit more clear. And you can still diagram this. Right, here's your angle C, here's your angle B. This is the substitution that you're doing. And again, these are two different formats for the same proof. This is the two-column format, and this is the flow map format. Sometimes, I might ask for one or the other. Oftentimes, I give you the choice as to what format you want to use.